Okay, these notes are ionic compounds with polyatomic ions. We're going to learn to write formulas with polyatomic ions rather than nonmetals. Okay, we're still going to use the metal because they are ionic, but it gets a little tricky. Okay, first off, a polyatomic ion is a group of covalently bonded ions. We're done covalently bonded. That means they don't come apart, okay? And they act like a single ion. For example, we have phosphate, which is PO4, and has a -3 charge. Well, it's a phosphorus with an oxygen there, one there, and one there. Okay? So it's covalently bonded. They're not going to come apart. Let's look at carbonate. Carbonate is CO3 with a -2. It also is a carbon with all these oxygens attached. Okay? So they don't come apart, ever. They stay together. Well, they do come apart sometimes. Some reactions can take them apart. But for the most part, think of them as one thing. Okay, now you have a reference guide. In the reference guide, you have a list. So the list on page 2 is a list of most of the polyatomic ions that we're going to go. By the way, it's called Table R5, just in case you're not sure what it is. So Table R5. Okay, starts out with acetate at the top, amide, acetate, all those good things. It's got a whole bunch of them. I am not going to make you memorize them. Well, a couple of them you'll have to know just because I use them so much. You've got to be able to recognize them. And I'll give you a list. There's probably like 5 or 6. And I'll give you a list, and we will have a quiz on them. All you're going to have to do is name them. I'm not going to make you draw the structure or know what the formula is for them. You just have to name them, okay? So I'll give you that list probably on Monday. Now, one of the things you're going to notice is all the polyatomic ions end in ate or ite, okay? They don't end in IDE except for 2 of them, hydroxide and cyanide. Okay, so when you write ionic formulas, you have to be able to distinguish between compounds that are binary, which means they end in IDE and contain a nonmetal, and compounds that contain a polyatomic ion, which means they end in ATE or ITE unless it's hydroxide or cyanide. I know, kind of complicated, but something you gotta figure out. Okay, so let's look at this. We're gonna write 2 formulas. The first one is aluminum phosphide. Now, phosphide ends in IDE. So, and since the IDE is not cyanide or hydroxide, I know that it is just P. It's phosphorus. I'm going to cross that down, and I'm going to get AlP. Now, the next one is aluminum phosphate. Notice the ATE ending. So I got the aluminum, and then I'm going to look on my table, and phosphate is PO4 with a -3 charge. Crisscross them down. Well, you don't even have to. They have the same charge, just like above. So you can just write it AlPO4. Okay, the next one is calcium sulfide. Okay, whoops, hang on. Now, this has got an IDE, so I know it's Ca with a +2, and sulfide, S with a -2, so CaS. The next one's calcium sulfate. Once again, calcium has a +2, but it's sulfate, which is SO4 -2. So I'm just going to write them together. Okay? Now, so far, what we've done is we've had polyatomic ions that have one polyatomic ion attached to it. You know, they've been canceling each other. The charges have been canceling each other out. That does not always happen. So what if you do have more than one polyatomic ion in the formula? So let's look at copper and cyanide. So copper is Cu, copper 2, so it has a +2. And then cyanide, when we look up the charge, is a -1. When we crisscross them, okay, you would think, oh, we'll just do this, right? Nope. That's not how you do it, because that does not mean 2 CNs. You have to do it this way. It's Cu. you have to use parentheses to put the Cn in and then put the 2 outside. That means there's 2 Cn ions. Okay, that's what that parentheses means. Okay, you must use parentheses to indicate that there is more than one polyatomic ion in the formula. When you look at the Cn, the Cn2, this little 2 here, means that there's 2 nitrogens, not 2 Cns. You need that parentheses. Okay, so let's look at iron 2 chloride. So iron has the +2 charge. Chloride has a -1 charge. Now when you cross this over, this 2 is going to go here. But you're not going to have 22, because that means 22 oxygen atoms, and that's not the case. So you've got to write it Fe, parentheses, ClO2, 2, okay? This 2 on the outside of parentheses. Means 2 ClO2 ions. Okay? So if it was inside, it would be ClO22, and that's just where there's no 22 anything. Okay? Okay, let's go to the next one. So we've got ammonium carbonate. Now ammonium is NH4, and it has a plus, and carbonate is CO4, or CO3, sorry, -2. So when you crisscross them down, you're actually going to get 2 ammonium ions, and then 1 carbonate ion. Okay? Tin 2 hydroxide. Once again, tin has a +2, and hydroxide has a minus. So when you crisscross them down, you're going to get SN parentheses OH2. Okay, last one. We're going to do tin 4 thiosulfate. Okay, now tin is SN, and this is going to be +4, and thiosulfate is, let's look it up, is S2O3. So S2O3 with a -2 charge. Crisscross them down, and you get SN2, S2, oops, don't forget the parentheses, O3 to the 4. Now, notice this, we have a 2 and a 4. And you know ionic compounds have to have the smallest whole number ratio. So smallest, so it needs smallest whole number ratio. Okay? So we're just going to divide everything by 2. So we're going to divide by 2, divide by 2. We get SN, brings it down to 1, S2O3, 2. Okay, just like if it was tin oxide or tin sulfide. Okay, same thing. Okay, well, that's it for tonight. We will try these in class tomorrow. So have a good night.